Creating Horizontal and Vertical Geometry. This is the second session of our 8-part webinar series for Open Roads Designer, How to Deliver from Survey to Plan Production. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any questions during the webcast, you can submit them through the Q&A widget. We will try to answer as many as we can during the live webcast. Please know we do capture all questions. The dataset for today's session and additional learning materials and opportunities are available in the resource list. We encourage you to download any resources or bookmark any links that you may find useful. For the best viewing experience, we recommend using a wired internet connection and closing any programs or browser sessions running in the background that could cause issues. Webinars are bandwidth intensive, so closing any unnecessary browser tabs will help conserve your bandwidth. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. Some networks cause slides to advance more slowly than others, so logging off your VPN is recommended. If your slides are behind, pushing F5 on your keyboard will refresh your page. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. An on-demand version of the webcast will be available approximately 1 day after the webcast and can be accessed using the same audience link that was sent to you earlier. If you're watching today's webinar with a group of colleagues, you can provide a list of additional participants. Please download the Excel file located in the resource list, fill in the information, and email back to the Bentley email address located at the top of the Excel file. Now, I'll hand it over to Kevin so we can start off session 2 of this Open Roads Designer webinar series.
All right, thank you, Catherine. Welcome, everybody. This is week number 2 of the Accelerate Open Roads series. Joey's going to be walking us through today, creating horizontal and vertical geometry. Now, we know we can't cover everything in our 1-hour session today, but we're going to try and do the best to hit the big ticket items in the workflow, just to give you some practical ways to get started in Open Roads. Let me just, a couple of things here I want to go over before Joey gets started. I want to pitch next week's session. Scott Urbis is going to be walking us through corridor modeling, including work with templates, point controls, super elevation, taking what Joey does today with our horizontal vertical control and building the model out from there. And that brings me to a good point to get everybody looking down at the resources section. If you click on resources down the lower right-hand corner, you can get the landing page there for the Accelerate Open Roads website. You do have to register for each session individually, so go ahead and click on session 3 and register there for next week's lesson on corridor modeling. All the data sets are provided also there in that resources section. We know that Joey's going to go a little fast today. He's got a lot of material. We want everybody to get value for their time today. So he's going to be going fast through the material, maybe a little faster than you can keep up with the data set. So make note that the session is recorded, and you'll hit the same link that you used to get into the session here live today. That same link later on today will become the recording. So be aware of that. And then you can follow along with the data set at your own pace and make full advantage of our session today. While we're going through the material, there's a Q&A box. If you click on that Q&A, we've got a team of experts ready to go to answer questions. So feel free to open that up and ask any questions along the way. We'll try to get those answered through the Q&A box. And also, Joey will be looking through those a little bit later, and we'll share a Q&A session after he's done with his technical portion. And then also in that resources section, just be aware that we have a learning path already created for you that'll supplement these series. These are quick 1-hour sessions, but it'll be good if you're interested in the area to dig in and do some more training in that area. Definitely click on that link to the learning path to supplement your learning that we're doing here together. And then also, there's a link in there for the next Open Road SIG, the Special Interest Group, which is going to be a really good one for those that are new, kind of starting out with Open Roads. And that's where we're going to take a look at some of the fundamentals of Open Roads Designer. And these are fundamentals that are new for people coming up from the previous products. And so we're going to be talking about things like 2D versus 3D modeling environment, how to handle file management now that all the data lives in the DGN. So all those fundamentals that'll help get you started in Open Roads Designer is going to be covered in that Open Roads SIG. So click on that link and register for that as well. And then the last item I'll talk about here before we get started is just a reminder that the 2020 Open Roads and Open Bridge Conference is coming up March the 16th through the 18th next year, 2020, in Orlando. It's just a good opportunity to come learn more about it, interact with all of us who are working with the products every day, ask your questions, share a lot of knowledge with other people that are using it in the industry. So that link is also there in the resources. So just one last question here. I'll push to the next slide. Want to take just a quick poll before Joey gets started, and this will help him kind of tailor his comments, know where our group out there is coming from. If you could answer this question real quick, what version of the Civil software are you currently using? Or you on SS2, SS3, SS4, or are you already up on Open Roads Designer? Hit the radio button there next to your answer, and then hit the submit button down at the bottom if you could real quick, and then give you just a couple of seconds to answer that. And we'll take a quick look at the answers so far. And yeah, it looks like the majority of folks there are running the SS4 products, so that's good to know as we get started. So we are ready to go with creating horizontal and vertical geometry. I will turn it over to Joey Llewellyn and come back after his presentation, and we'll do a little Q&A. Thanks, Joey.
All right. Thanks, Kevin. And thanks, everyone, for taking the time to join in. I have the agenda here on the screen. So again, just to set the agenda for the course of the next hour, 3 hours. I'm joking. The next hour, 45 minutes to an hour. We're going to go through, first of all, I want to explain the objective, meaning what are we designing here? What are we trying to accomplish throughout this 8-week series? This is a real project, a real data set in the real world. So that means there are real design constraints and criteria and needs and nuances that we're trying to adhere to. So I'm going to talk about the objective first of all. Then from there, hopefully that gives you a perspective of where we're trying to go over the course of the following weeks. And then we're going to create the geometry file. As Kevin mentioned, if you're new to Open Roads or Open Roads Designer, the data lives in the DGN. So we're going to create a new container, a new DGN file that will be the container for our geometry. Then we'll create the horizontal geometry, including the center line of our corridor. In addition to that, a couple of tapers so that we can horizontally meet and match the existing pavement within the existing roadway corridor that we're working in. And then we're going to create the vertical geometry, and that includes a new PGL that we're going to model against. Scott's going to model using that PGL next week, and then also a couple of, well, probably one, we're going to focus on the western end in this case. Vertical transitions. The roadway currently is bifurcated vertically, meaning they're at 2 different elevations, and you'll see that as we go through here. So we're going to create those vertical transition areas in the geometry as well, so that they can be control lines when we come to model that roadway corridor. So that's kind of our agenda, and so let's kind of get started here. So I'm going to start off, I'm going to just create a file, and then we're going to circle back and talk about the objective of where we're trying to go here. As noted, again, I'm trying to do this in a sequential way for those of you following along with the data set. We're going to use the current workspace training examples, and we're going to use the work set called Training Imperial. These are delivered with the product, so you have them. If you use an Open Roads Designer, you have them. And then we're just going to go ahead and click and create a brand new file. Now, as we're creating this file, we're using the specific seed file delivered with our data set. So you can browse into that data set. There's a folder called seed. Select the Highway 72 seed 2D.dgn, and we are using a 2D file to create this, and I'll get into that as we go through as well with a little explanation behind how the 2D and the 3D work together. So we're just going to type in a name, proposed geometry here, and let me browse to the proper place to where I want to store this. And so I'm going to just place this in my session 2 data folder, and we're ready to click the save button. So we're going to create that DGN. It's going to go through creating that, and I'm going to just, again, click back over, and while that's happening, I want to start and get into, again, the objective. Why is creating geometry a little more complicated than just a horizontal and a vertical down the center of the roadway? So here's a representation of the model that we're going to construct going forward. Now, for us in this session, as we begin to think about what we need to develop geometrically for this alignment, one, you can see the tapers horizontally as we are, again, moving from the existing roadway corridor into our widened section. Our goal is to widen the pavement to the interior. Okay, so we're going to add 12 feet and shoulders to the inside of this divided, and it's bifurcated vertically roadway. Okay, now in doing that, you'll notice as well, we want to do a little work and modify the PGL between these roadways. So as we widen to the middle, we don't want, if you'll notice the existing roadway is quite a bit higher here, we want to be sure and maintain a more level elevation between the 2 roadways from left to right. Okay, now if we go back to the beginning of the roadway, as we look into that transition, you'll notice again we're going to have to modify the vertical between the eastbound and the westbound sides of the roadway. So we'll have to again create that control line vertically, but you'll notice the PGL that we're going to create is in line with the eastbound roadway. The eastbound roadway, we wanted to maintain its current location just for grading outside and right-of-way constraints, as well as driveways, intersections, and some other things along the roadway corridor. So we're holding the eastbound side. We're going to widen to the inside and create a new PGL along that widened pavement. Okay. We will modify again the eastbound lane, to meet existing both horizontally and vertically, and then we'll transition that back down to again our level or our even PGL. And as we walk through these sections, you can see now our elevations from westbound here and eastbound are equal at the same PGL. And so really that's our objective throughout the course of this project. Again, we're creating the geometric layout for that today. And so hopefully that gives you kind of a perspective of where we're going and why we're going to create the things that we're going to create today. All right. And as you see, as we go down the corridor, you can see as we move into the bridge area across the creek, you can see that in the sections as well. All right, so let's move back. We have our file here. This is the file I just created, propgeometry.dgn. Now, if we go back, continuing our workflow, again, we began this process last week where Kevin took us through reducing the survey data. We brought that in. Kevin went through the terrain modeling aspect, correcting rod heights, joining brake lines, and so forth to get the topo where we wanted it to be. Now, how do we bring that data in so that we can use it to create horizontal geometry? Well, since everything lives in the DGN, we're going to use reference files. So I'm just going to go into my references dialog box, browse out, and I'm going to go and attach several files to get me started in this session. I'll browse to the survey folder. I'm going to select both the survey base map, which this is from Kevin's work last week, as well as a couple of files. These are the terrain of the deck of both the northbound and the southbound bridges. So I'm going to just bring those, reference those in, and I can fit the view. So we have that displayed. And I will mention too, the coordinate system is in this in the file. So it is set in the file based off the seed that I collected, or the seed that I used to start this, that I based this file from. So just to make a note, we are using the seed file, which Kevin set initially last week, and it is present in the seed file so that we're consistent going forward. Okay. All right, so we've brought the survey data in. Again, this is relative to what Kevin did last week. In addition to the survey base map and the 2 bridge decks, I'm going to bring in the terrain model as well. Kevin separated out the terrain model from the actual topo line work, and so that's when we have a base map file and a terrain model. Those exist in 2 distinct DGN files, okay? And so we'll get started. So we brought in the survey data. We have the train model available to us. And so now we can take a moment, again, take a look at the topo that we have and see that representation. And don't forget, we are in a 2D file, okay? We'll get to the 3D, and again, I'll build on this as we go through. Now, in this instance, we are more or less going to hold the horizontal location of the existing center line. That's our objective. So what I have, a couple of things to point out. There's an existing centerline monument located off the topo. This was picked up in the survey. So we have an existing monument on the western end, and there's an existing monument on the eastern end as well. Okay, so we have some known monumentation to sort of begin from, to hold to. Now, in terms of that as well, is what do we know about this alignment? And I did this. This is in your data set as well. There's a PDF file that represents the existing horizontal alignment, and we're going to use this as the basis from which to create our horizontal center line for Highway 72. So here's the output. This could appear in the real world on a set of old drawings that you have. Again, this could be in a report. This could be in different places, but we're going to take this as the known horizontal geometry, and we're going to begin constructing that geometry. Now, I'm going to start, and I'm going to lay this out first of all graphically. So I'm going to go to the Open Roads Modeling workflow, go over to the Geometry tab, and again, I'm going to lay this out graphically by elements, meaning I'm going to draw tangents, I'm going to draw arcs, and so forth, and then put them all together in an alignment, adhering to that known bearing distance, curve radius, curve length, and so forth. So to begin, again, we're on the Geometry tab. We'll get on this area under the Geometry Tools, and we're going to begin by just placing a line. Now, before I place that line, I need to point something out, and let me just pull this here to highlight a couple of things. Before we begin to place geometry, it's probably best if you go ahead under that menu and click the Standards drop down. And if it's not turned on already, and it may not be, go ahead and turn on what's called the Feature Definition Toolbar. And that opens up the dialog that you see here. And the Feature Definition Toolbar, we'll use that throughout this session. And you can dock it, as I've done here. You can dock it in different places if you want to. The Feature Definition Toolbar allows me to pick the feature definition and apply it actively to every element that I create going forward. So I'm going to click this button to make the feature definition that I select active, and I'm going to select Geometry Baseline. And that's going to be the feature definition assigned to these elements as I create them. And so to begin, again, I go back to my horizontal geometric element to place it. And I'm going to select the start point. Again, I'm doing this graphically. I'm going to zoom into this known monument, and I'm going to just select. Notice there's elements there graphically intersecting one another. I'm going to use the intersection snap and jump to that point, and then begin laying out my first element within, based off, again, my known geometry. And you'll notice as you draw that element, you've got heads-up prompts. You'll notice those on the cursor. And I'll try and explain those. On those heads-up prompts, number one, you can key into the highlighted field, as well as the arrows indicate that I can move between information, left or right. So I click the left arrow or the right arrow, or right if I want to, and it tabs me through distance and direction that I can use to input data for this particular element. All right? So I'm going to leave it on distance, and I'll just jump back over to this PDF. Since, again, this is what I'm adhering to, I'll see that first distance is 790.66. So I'll key that in. I'll click the Tab key or the Enter key. And this is the interaction part with that dialog, okay? To hold that value, I'll type it in and click the Tab key. Now that locks that value in place, meaning I have a fixed 790-foot segment. The bearing is still free so that I can move that in any direction I want, but the distance is locked. Now I want to input the bearing, so I'll click the right arrow, and I get the field to input the bearing for this particular element. So we'll note it's south 890228 east. So I'll show you how to key that in first of all, and then we'll move a little faster. So it's 890228. So to key this in, I'm going to key in south 89, and I'm going to use a colon, and I've forgotten that number already, 890228. So it's south 89:02:28 east. Okay, south 89:02 28 seconds east. And I click the tab key or the enter key. They both lock, and you'll see that it picks that up as a field. Now to place that element, again, if you're new to Open Roads Designer and the interaction, to place that element, I need the data point. And that places that element now in the file. So now I have that first tangent element placed. Okay, now we're going to continue on. We're going to continue using geometric tools to place the curve in the next segment. So I'm going to go back up into the horizontal area. I'm going to pick arc from element, and I'm going to use this tool, simple arc from element. Now what this does, it's going to, well, you'll see what it does. I'm going to follow the prompts. It's going to place an arc off of that initial tangent. I'll select the element, and then I'll select the start point, meaning the PC of this particular curve. I want that to start where my tangent ended, so I'm going to snap there, left click, and I'm going to begin laying out this curve. Okay? Much like with the tangent, I have a heads-up prompt with a field where I can input data. So for the radius, if we refer back to our existing information, we'll see the radius is 2002. So I can, again, key that in, click the tab key to lock it, and now I have that radius placed, and I can data point. I'll hold that radius, and the arc length now is varying. If we go back into our report, if I don't like to key in at this point, I can just cut and paste. Okay, so I'm just going to grab and cut and paste out of that PDF. Again, I have to click, once I place the data in the field, I have to click the tab key or the enter key to lock it. And then I'll data point one last time to place it. Notice it's prompting me now to trim or extend, which it's going to do that when I place this every time. I can tell it to trim or extend, meaning fill in the gaps between the incoming or outgoing tangent, depending on how I'm doing this. And I'm going to leave it back. So it'll trim back to the next element. All right, so we've placed a couple elements, a couple more to go. So we're going to place the next tangent element that is going down. It's 2,000 feet long that goes across the bridge and into the next curve. We have the bearing, and we have the length as well. So pop that open. Again, we'll go back to place that horizontal tangent section. I'm going to snap that graphically. So I'm using a microstation snap and place this down this way. Again, it's a matter of inputting now the distance and the bearing, both distance and bearing, to completely define this element. So the distance is 2089.24. Key that in, click the tab key to lock it, and again, I'm back to the fixed length. I'll push the right arrow once more to move to the bearing. Now again, I can key that in, as I showed you previously, using colons to separate degrees, minutes, and seconds, or I'm going to shortcut things just a little bit and cut and paste. Again, though, I have to push the tab key at this point to lock that value. Okay? And then data point once more to actually place it in the file. So that's the next element is placed. Now, I will take a moment here because I want to point this out to you. As you're inputting data, as you're creating geometry, and as you're laying these elements out, it's okay if you happen to make a mistake. You key in the incorrect value for the bearing or the distance or whatever may happen. You can change that very quickly, meaning if you'll notice here, as you select that element, the dimensions, the bearing, the distance are active. I can click on either one of those dimensions directly and make a change. Okay? So it's really no more difficult than that. Okay? So again, just as an FYI, in terms of interacting with the data, click on those dimensions if you need to correct something. What was that number? 2089.24. Got to remember the correct number. 2089.24. And there we go. All right. So again, just a little quick tip there as you're beginning to use Open Roads Designer and get comfortable with these tools. One last arc to input. So we're going to use the same command, arc from element. I'll follow the prompts. Set the beginning of the arc or the curve at the PC. The last curve radius you'll see is 7476.52. Again, input that data. data point to accept it. Okay, and then we define the length, 642.89. Again, tab that, and then data point to accept, data point to trim back. So at this point now, we've created that baseline. That's all good. That's done. We've got the elements in place. Now we need to complex them together. Okay, so we have built this in a way using elements, piece by piece, element by element. But now we need to join them all together. So we'll go up to complex geometry. We're going to complex by element. And we'll begin. I'm going to do this manually first of all. When you run this, it will recreate the feature and you have the opportunity to rename it. So what I want to do is name this Highway 72 Centerline. Okay, whatever name you want to call it. And now, I'm going to do this manually in order to just show you something. You'll notice as I move onto the element to begin picking the first element, what I want you to note is that purple arrow on the east end of the element. That purple arrow indicates the direction in which it's going to join elements. Okay, that's the direction of the element that it's going to create or that it's going to join. Okay, meaning stationing is going to go in that way, in the way of the direction of the arrow. Now, notice where my cursor is. If I move and I select that element on the opposite side, notice what happens to the arrow. So where you select the element has a direct impact on the direction of the element. Okay, and I'm showing you that just so that you'll avoid potentially picking the element in the wrong end and then putting them in the wrong direction. Okay, so we're going to pick it from the opposite side, the western end. So we're moving in the eastern direction. I'll select it, and then I'm going to go through selecting each element in the same direction just to be sure I'm sequential. And click through there and data point, and now we have our center line created. Okay, so we have now created that baseline, that horizontal element. Okay, and we did that again using kind of a graphical elemental method. And this is not the only way I could have created this. I could have created it in different ways graphically. Okay, that would have been okay to do that. So this way I adhered to what we knew to be existing and then drew that in graphically. Now, I want to show another example of creating this horizontally while we're here. In some ways, you might want to lay out your geometry in a tabular format. Okay, so I'm going to show you one more method. Again, just to make you aware of it, you might find it more useful depending on the criteria that you're working from, the data you're working from, and the methodology that you really want to employ. So I'm going to turn this particular horizontal off, and I'm just going to turn it off by level. All right, so it's there, it still exists. I just turned the level off behind the scenes. And to create this secondary baseline, I'm going to change my feature definition to temp. Okay, so this secondary alignment we're about to build, again, I just want to do this to expose you to know that there's another method if you'd like to use a tabular workflow to create this horizontal alignment. So this alignment is going to be based off of the feature definition geometry temp. And to create it, we are going to go under the horizontal tool set, under complex geometry. We're going to use this tool called Geometry Builder. And so it opens up a tabular interface. It's pretty straightforward, not terribly complicated. You're going to input that horizontal alignment, element by element, line by line. Okay. Now to begin, we're going to create sort of an empty container. So this will be our geometry name, and we'll just make that temp. I can select the feature definition. I could pick a different feature definition. In this case, I'm going to use the active feature definition since I've already set it to be geometry temp. Okay. And then make sure I pick the, okay. And then I'm going to begin building that alignment. Okay. So over here in this dialog, I have to begin constructing the alignment, and it begins with a known point. Now, let's do a quick drop back here and let's look at where we are, where we're starting our POB at. Okay, our POB, we have known coordinates based off of that monumentation that we have in the file. So that's here. Again, we could cut and paste that, or graphically we can use this point and select that monument, or in this case, I'm going to select the intersection of those graphics to pick up those X and Y locations within, and we can compare those back to, let's pull this down. And so we can compare that X and that Y back to our, again, our known coordinates as we begin our alignment. So that's the POB for our alignment. We've got that set. And then we go through and we input each element. Linear, arc, linear, arc, linear, arc, just as we did before, except in a tabular method. Now, using this dialog and using it for what we're doing here, meaning we're creating a baseline, there's a couple of things I have to do. I want to be sure and make sure that every element is tangential, and I want to go ahead and create civil ruled elements, okay? And that's fine, meaning these elements will have a relationship to one another and how they're created that allows me to dynamically modify them after the fact. All right, so I can go through this quickly. I can cut and paste bearing and distance from distance 790.66. And then I'll tab. Now that begins to create that element, gives me a graphical representation of that element piece by piece as I create it. Now again, I just click on the next line. I want to change this, or the next row, and let's change this to an arc. Okay, so this is a curved element, and then I want to input, it's asking for, this is a clockwise curve, and it's asking for the radius and the length. So let's move down. Our radius is 2002. Key that value in, and the length for our curve is 1144.65. Okay, and then I'm clicking the tab key to place that curved element. All right, and then you just go through the sequence doing this. I don't want to dock that. And then keep those elements working, piece by piece, line by line, row by row, as we create this, okay? And so we have the next element. As a line, I need the bearing and I need the distance. It's picked up the bearing based off the curve. The length of the next element, 2089.24. Okay, we have that placed in the file, and then we have that last curve, and we'll scroll down the radius of the last curve, 7476.52. And the curve length is 642.89. All right, so again, I went through this really to just demonstrate a couple of methods to place this horizontal alignment. Now, once I have the data input, meaning I've got the rows and columns filled out properly, I have a temporary display of that element. And so I could cycle back through those elements individually. I'm going to delete this row. I don't need that one. So I could cycle through here, and you'll see the elements highlight below if I need to make modifications at this point. Now, this alignment hasn't been written to the file. To write it to the file, I'll click the place button. So when I click the place button, now I have that baseline written into the DGN. So it exists now in the DGN based off of the parameters that I put in the table. Okay? And so as I click on it now, you see that it's a ruled element. I have bearings, distances, curve radius, and information available to me to make modifications if I need to. All right, and that's again using the geometry builder to create that element. Now, I'm going to switch. I don't want to use this particular alignment since it doesn't have proper symbology on it. So bear with me here while I change. Let's go modify our display here just a little bit. Okay, that's on our default level. And let's turn on the proper geometry. There we go. So that's the proper element I want to see. Now, since this is on the default, let's make this real simple. I'm going to just remove it so I have no confusion whatsoever. And I'll turn back on the proper featurized horizontal alignment. Again, that's using geometry baseline, which is what I want to adhere to in the file. Now, that alignment starts at a station of 0. I need to modify the start stationing. And I want to display the stationing as well. So I can go up to Drawing Production, go to Element Annotation, select Annotate Element. I'm going to go follow the prompt and select the actual baseline. Okay, left click to select it. I'll right click to complete the action. And so now you'll see the baseline's been annotated. You'll see the stationing starts at 0, 0, and I want to make a modification to that. You'll notice in our report, this project's going to start at 500 plus alt alt. And so we need to modify that start station to match that criteria. Now to change the start station, we'll go back to the Geometry tab, move over here to under Horizontal, select Modify, and we're going to modify the start station. And again, I'm following the heads-up prompts in this case. Locate the element, go to the alignment, I want to modify the start station. The start distance, this is where the station will be applied along the baseline. Now, this is important to point out too when it comes to interacting with dialogues. You'll notice that that value is locked, meaning I can't change it at this point. I could change it. Let me take that back. I could key in another number if I wanted to. But let's say I want to free up that cursor to move up and down the alignment to snap to another point easily. To remove the lock from that field, you push the End key. Okay? So let me say that again. If the field happens to be locked, and this is applicable throughout the product, if you want to unlock a field, an input field, press the End key. Okay? And then that allows you to have a rubber banding type of graphical interface where you could snap to another element or so forth. Okay? Now, in this case, mine's pretty simple. I simply want to go to 0. So I can key in 0, click the Tab key to lock it, and that's going to jump me back to the beginning. Then I'll left click to accept that answer. Now, what do I want my start station to be? Again, I can key in a value here. I'm just going to move it to 500 plus 00, which you see in the field. So I'll left click to accept it. And then data point again to accept that change. And you'll see now the stationing along it's changed as well. Okay. So we now got a horizontal alignment. The stationing is based off of 500 point alt alt or plus alt alt as our POB. And we're ready kind of to think about the next step in our process. Okay. Now, one thing here too, let me point this out. In terms of horizontal geometry, and we'll continue to see it in vertical geometry. OpenRoads Designer does contain design standards. And let me pull this toolbar out. And let me show you if this is not on by default. Again, if this dialog you see here, this toolbar, is not on as you're working through this data set, browse up to the Geometry tab, open up the Standards drop-down menu, and you want to open this toolbar, Design Standards toolbar. You'll open that up. You'll see the toolbar you see on the screen here. And again, that can be docked. You can move that wherever you want. And using that toolbar, we're going to be able to select our design speed that we want to use for a particular alignment. So in our case, we're going to use a 4-lane based off of 2018 standards. We know we're going to end up somewhere in an 8% maximum for our super, and we're going to use 70 miles per hour, which is the current design speed. It's posted at 65 for our horizontal alignment. Okay. Now, this is based off of, again, the AASHTO standards for 2018, 70 miles per hour. Now, I have 2 buttons here. We're going to use this particular button. If I hover over it, it says Set Design Standard. So I click that button, I follow the prompt. I'm going to apply that design standard to this horizontal alignment that we just created. Okay? And so that creates that standard associated now with this horizontal alignment. And you'll notice that I get some glyphs, highlighted areas along the alignment. Now, if I hover over that particular glyph, you'll notice that this large curve that we've input based off existing doesn't meet 70 mile per hour design standard. Okay, our actual value is 2002. According to the standard, we should be at 3150. Okay, so in this case, again, doing our engineering, we could think about modifying that. We could get a design exception based off of the existing conditions and what we know about the road already, or we could lower the speed limit. Okay, but I just want to make you aware that those standards exist. They can be applied to horizontal, and you'll see later vertical geometry, and you can use them in your design steps as you're laying out geometry, or you can come back and assign them after the fact. Okay. All right, so there's our horizontal. We've got the horizontal created. We've created in a couple of different ways, and now we have to move to the next step on our agenda, which is create the vertical. Oh, before I do that, I almost forgot. I've got to create the tapers. So let me add in, realizing we've got to modify the horizontal edges of pavement to match our existing roadway. Let me go here, and I'm going to add in this proposed layout.dgn. Again, I'm just referencing this file in, and you'll notice we need to taper this horizontally to match where we're going to tie back into our existing roadway. Okay, so we have to create, or I'm going to create, these taper elements using civil or open roads geometry. Currently, these are just microstation lines. This is just a graphics file of the proposed layout. And I'm going to create these so that Scott can use them next week as control lines to control his width of pavement. All right, so to do that, I'm back under the geometry tools. I'll go under the horizontal menu, go to offsets and tapers. I'm going to use this command called variable offset taper. And again, I'm going to follow the prompts. Let me pull this dialog over so you can see it. Now, I can input data on the menu. You can do that in terms of how to use the software, or you can use the heads-up prompt. You still have to go through the prompts either way, but here we go. We're going to create this element. So I'm going to base this taper off of my baseline that we just created. I've got to fill out the parameters. I want this offset to start. Our start station's over here. So I want this to start at a 24-foot offset. Okay. So I keyed that in, clicked the tab key, and let me change. I'll come back and change. Well, we'll leave it at temp for now. I'll change the feature definition just a second. And we can modify the names on these. I could call this westbound EOP control as I'm creating them. And so we got the offset in. We've got it defined. You can see it moving along our baseline. I have to push the right arrow to move to the location of that 24-foot offset along the corridor or along the alignment. So now I need to pick the starting station. Where does this transition begin? I'm just going to graphically move up here, select that endpoint of the graphic, and now I'm going to be prompted to define the taper as we work along the baseline. Okay, my end offset will be -16. Okay. So we see now it overlays the graphic. Again, I'll push to the right, and you'll notice I have a couple of data fields here, an additional one. I can put in the set distance for the taper, which I'm going to set the taper at 275 feet, which you see that keyed in the field. Then I'll data point to accept it, leave mirroring set to no, meaning I don't want to mirror this to the opposite side of the alignment. And now we have an additional geometry element built. And so now I'll do that on the opposite side as well. Okay. Now I'm going to skip that for the sake of time because we have a lot to cover. But we have that taper created. Now when Scott comes to model this next week, we'll have tapers created on both sides. But for the sake of time today, you've seen that workflow. We reproduce it on the opposite side, and that will be available in the corridor next week, again, to manage those tapers. So let's talk about now the vertical. How do we create the vertical alignment? What do we need to think about? And in terms of what do we need to provide for the modeling of this roadway corridor to handle and control the vertical? Well, we need to create the PGL, of course. But then you might ask yourself, all right, I want to take into account elevations and vertical aspects, but I'm in a 2D file. How does that work? Okay. Now what I want to show you is kind of fundamental to Open Roads Designer. I'm going to open up an additional view here, and I want to show you something, how we move between 2D and 3D in Open Roads Designer. So I now have two views open. You'll see that view 2 is really just a different display attribute, but it's the same as what's in view 1. Now I have the terrain model loaded. I want to select that terrain model, and I want to click Activate. That sets the terrain model active. Not only does it set the terrain model active, by activating any element, any design element that has 3D in it, meaning some sort of elevation definition, in addition to that, making it active, it also creates, and this Open Roads Designer does this for you, but it moves all of the project data into a 3-dimensional model. So now the data that I reference to my original 2D file has now been placed in a 3D model as well. So the elevations from my topo, the elevations from my resulting terrain model, all that data is in a 3D model in my DGN and available for me to use. Okay, and that just happens as soon as I activate any element, a vertical alignment, a terrain model that has an elevation on it. Okay, so now we've got 3D data, we've got our horizontal alignment laid out, and we want to think about creating the profile grade line. Okay, now you might ask yourself again, how do we do that? How do we interact with the data to get a profile created? There are dynamic views within Open Roads Designer that we take advantage of. So I'm going to select the horizontal, and I'm going to go and open up a profile model. So I'll select that button. I'm prompted to select an open view that's already opened or open an additional view. So I'm going to go and I'm going to select view 4, and I'm going to data click in view 4. Okay, so I'll just data point, and now from the baseline, the horizontal geometry that we created and the active terrain model that underlies it, we see the profile of the existing ground along our horizontal alignment. Okay, so we now have that profile open from which we can start, or in which we can start creating our vertical. Now, to create this PGL, bear with me, I want to show you this. Now here, this might make it a little bit clearer. Again, for the PGL, remember where we're going here. We're going to create the profile grade line for this section of roadway that we're widening. We need to widen it again for traffic, for safety, and some other reasons. But we want to base our new PGL off the westbound side inside edge of pavement, the widened inside edge of pavement. Okay? So that's where we're going to start. We're going to base the PGL off of the widened inside edge of pavement. Okay? And that's where our PGL will be. You'll notice these hold elevation with one another. The eastbound will vary as we transition in the bifurcation and throughout the corridor, okay? So we need to create this elevation, the PGL, that holds to the inside edge of pavement within our westbound corridor. Now, how are we going to do that? All right, how are we going to do that? Now, cross-sectionally, if we look at this, you'll notice in those cross-sections, you could see what was going on. I can open up cross-section here. Let's open up a dynamic section. Just again to give you a little perspective of what we're doing. Lost my view. Let me open up the additional view here. All right, let's go through that again. I'm going to set the offset on the section, the offset left, the offset right, a start station, which I'm going to hold at 505 even. Again, this is just for the cross sections themselves. And data point in the view. And so now we can see those sections, and we can scroll through and see visually now the sections as we begin to work as well. Now, the sections have bearing on what I want to show you. As we cycle through here, if I exaggerate this a little bit, you'll notice, again, the elevation difference between here. We want to minimize the elevation difference between the two sides of the roadway in our new corridor. So again, we want to hold a widened inside edge of pavement. Now, how am I going to locate that inside edge of pavement horizontally and vertically? What I want to do, I'm going to use a little bit of a creative workflow potentially. I'm going to go to model detailing, and I'm going to use what's called a linear template. Okay. Now, to do this in your exercise, you first need to go to corridors. You need to open up the particular template library that we delivered in the data set. So you'll go to create template, go to file, go to open. You'll browse out into the data set under templates. You'll open the file called session2.itl. Okay. And then in that template library, you'll see this template simply called widening. And this is a pretty simple, straightforward template. It does nothing but follow the existing pavement. You'll notice how it's pivoting about the edge, and it follows the cross slope of the existing pavement and modifies the widened pavement to that existing cross slope. Now we're going to apply this template to the edge of pavement from the survey, and we're going to find that new PGL. Okay, so let's run that. We're going to apply that linear template. I'm going to follow the prompts, and I'm going to move a little faster for time's sake. Start station, we want to go along the length of the entire element. I want to pick the left or the right. Which side am I going to create this widening to? I'm going to create it to the south side, so I'll move the cursor to the south. Data point once more, and it'll process now that template along my roadway corridor. And now you can see the result in both 3D and in the cross-section view. All right, so the interaction here is very, very dynamic. Whoop, where'd my view go? Let me bring that back. So the interaction, again, is very dynamic in how we're doing this, and how you're able really to interact with the data. You can see it again in the 3D view. Click the right active view. So we see that widened pavement section. And again, this is temporary. We're only doing this to locate where we want the PGL to be. Now, I'm not going to do this on the south side of the road again for time's sake. We would reproduce this exact same workflow on the opposite side of the bridge. The edge of pavement features are two separate features based off the topo. Okay, so I could reproduce this on the opposite side. Actually, I probably need to so that we can get a good PGL line here. And I'll show you completing that before we're done. So I'm going to move quickly. Let's run here. We'll apply the linear template. Follow the prompts. I'm selecting the existing edge of pavement, again, from the survey features. Go through the prompts. We're using the same template, same methodology. Be sure to make sure your cursor's on the right side of the road that you want to widen to. And then we'll data point again to process that. Now we have that widened section on both sides of the bridge. We can even, well, we won't worry about the bridge at this point. I'll project it in a different way. But we now see that PGL based off the existing cross slope and widened. Now, I will point this out. In this case, for time's sake, we did not take into account, although we may do this at a later session in a SIG coming up, we're not taking into account super elevation correction in this or milling and overlay. Again, our focus is geometry, so we didn't go through that process. We may pick that up at a later date in a separate, maybe SIG session. But we've located now this point that's going to be the basis for what will become our PGL. And now we need to show that on the profile. So I'm going to go back to the geometry tools. I'm going to go into now the vertical section. Let's turn this off, clear up our view a little. And now under the vertical menu, I'm going to go into profile creation and I'm going to project a profile to an element. Okay. And so now I'm just going to take that edge of pavement feature and I'm going to project it down onto the baseline in data point. And now we have that feature or that graphical representation of the widened edge of pavement in the profile. So that's taken care of. We'll follow the same process. Put it on the other side. Again, let me pick the right feature. That's my fault. Pick the right feature. Project it onto the baseline on the opposite side of the creek, and now we see that. And we can do the same with the bridge itself. We can follow the same process, and now we can see that new edge of pavement that we want to hold for the PGL. Now, in creation of the PGL, we're going to use this as the basis for that creation. So as we jump in now, we're going to start using the vertical alignment tools. And I know we got a few minutes left before we get to the hour, so I want to make sure we move kind of quickly. There's things I want to cover here. I'm going to focus on the western side of our alignment so that I can make sure we get everything we need to show in here. Again, just to make sure that you are, again, expose you to what the functional, most important tools and workflows are. So I have that edge of pavement now projected into my profile. That becomes the visual guide for me to create the new PGL. So I'm going to go back into the vertical alignment tools. And at this point in time, I actually am going to toggle on the design standard to be active while I'm creating the profile grade line. So in this instance, the curves that I create, the vertical curves, will adhere to that design standard. And I want to be sure and reset my feature definition back to geometry baseline. So I'm going to go through this. I'm going to start out with just a tangent section, again, using this as my guide. And so I'm drawing in the profile window. This is a vertical alignment tool, and I'm going to pick a start point. Okay. And this start point could be done. I can graphically snap. I can do, I can graphically snap. I could use Civil AccuDraw to key in a specific station. So in this case, if I turn on Civil AccuDraw, I'm going to activate Civil AccuDraw. I could key in a specific station to start this element, which maybe we want that to be 505.8. And I'll, again, tab key to lock, and then I can lock in a specific elevation if I want. Tab key to lock it. Data point now to begin drawing that element. So Civil AccuDraw can be used in profiles as well, okay? Now, as we're laying out this element, I'm going to lay tangents, place tangents, and then fit arcs between them in this workflow. So this first element, we can draw this out. I'm going to hold to a 2.75 grade. So I'll key that value in, and you can see that value. I can actually zoom out. You can see that it fits a little better than maybe it appears. And then draw that segment in. So I have a tangential segment along that curve, or along that edge of pavement. It's that uses, again, that proposed widened edge of pavement using the existing cross slope of the road. And then I'm going to go down. I'm going to click, and I'm going to follow along. Again, I'm just snapping so that I follow along this graphic, and I'm going to create the next tangent segment. Okay, the next tangent segment, as I draw it out, I'm pushing the right arrow, and let's hold to 5.25. And then we can just, again, we're sort of just graphically inputting these values. And let's go to the next tangent area. Again, same process. I can follow along here. And the next section, we want to hold to a 3% grade. Okay. And then finally, on the very end, we've got just a small tangent. Since we end in a curve, let's jump. I'm going to snap there, and we'll make the last segment a minus 1.25. And place that. Now let's insert the curves based off of, again, our design standard that is being applied. To insert the curves, I'm going to go again into the vertical tools. I'm going to place a curve between elements. So parabola between elements will be the tool that we use. And I'm going to select each element, each incoming and outgoing tangent. Now, as I move the cursor around, you'll notice now it's holding to a K value. That vertical curve parameter that you see at 247, that's the K value based off the design standard. Okay, so I'm going to data point to place that. Data point once more so that I connect the tangents with the curve, and I'll move to the next curve. Select the elements. Move the cursor. You'll notice it flips from side to side as I move the cursor. Move it to the proper place. It's holding 181 as the K value based off the design standard, and then I data point to place it. Then I'll move to the last curve set. And again, move the cursor. You'll see the answer before you data point to accept it. Data point to accept that curve. Data point to trim the elements. So at this point, we kind of are in the same place as we were before. We've got individual vertical elements, okay? And now we need to put them together. Now to do that, let's fit out. We'll go here. There's complex geometry. Be sure to use the complex geometry tool under the vertical tool set. So I'll click that. And to do this more quickly, I'm going to set it to automatic. We'll call it Highway 72 PGL. And then just as before, I need to pay attention to the direction of the arrow and data point, and then accept those elements. And now we have the PGL created for our roadway corridor based off the widened inside edge of pavement. Okay, so we have the PGL created, again, based off of that widened element. I can now set that PGL active. This is key too. That PGL, that vertical alignment, exists in association with the horizontal baseline from which we created it. Now I will hover over it. I will select Set Active. Now that makes that vertical alignment the active vertical, meaning the stations, elevations, and so forth are now tied and active in the 3D model. And you can see the actual representation of the 3D PGL in the design model. All right, and that happens by setting it active. Now, one final task, and I know we're right at the hour, but I just want to be sure we cover this. Remember, we have to control the transition at the end point, at the eastern and western points of our roadway corridor. If we look at the sections in that area, remember, if we look at the sections, this view is there. I just had it turned off. If we look at those sections, if I exaggerate the view a little bit, you can see we need to, again, modify the eastbound roadway corridor so that we transition the bifurcation, the bi-level, the two different levels from our project area into the existing elevation of the roadway. So we're going to create an additional vertical element to do that. And we're going to follow the very same process we've used before. We're going to project the eastbound edge of pavement onto our profile and create a vertical alignment from it. Now to do that, let's go back into our vertical tool set. We're going to select under profile creation, we're going to select project profile range to element. We don't want to project the entire element. We only want to project a portion of it. Move over, select our baseline. We're going to start at the far western end and we're going to display it through maybe right there. That's a data point. Now we see that feature in our profile window, and that will become our guide for creating the control PGL to control the elevation of that roadway segment. So I'm going to do this quickly. So again, you have the data set. You can follow along in the recording later, but I want to go ahead and complete this. So I've got my guide here. I'm going to move up. Let's change this just to make it a little more simple. We'll go, well, let's just leave it. Let's leave it baseline. That's fine. We're going to create the vertical tangent first. Again, I'm going to snap here so that I'm following this. I want a smooth transition. Okay. Let's snap our vertex to there. So I now have an additional geometric element based off of that graphical display of the edge of pavement. And now I want to control the transition into that, again, common PGL area, non-bifurcated area. To do that, I'm going to go back. I'm going to use profile line again. I'm going to just take and draw a tangent area. Again, a straight vertical line. Now I'm going to use the tangent snap in MicroStation, the MicroStation tangent snap. Whoop, let me get this view proper. And I'm going to be sure and select a tangent location to my PGL, okay? And data point. And so now I have a taper that's tangent again to that vertical curve. And I'm going to just insert another curve between my elements. So as I zoom in, bear with me, I'll select each of those elements. Let me select each element. let's back out, make sure I've got there. I want to be sure and select the geometric element and place that arc. Be sure you select the geometry that you created, not the graphical representation of the pavement. Now at this point, my K value is at 247. It's locked based off the design standard I have placed, or I have told it. So I'll data point through the prompts, and now I have that vertical control line in place. I'm going to delete the graphical representation of the edge of pavement so you can see this more clearly. And I'll complex them together. And again, we will name this EB I'll call it EB control for this. And again, it's just a matter now of selecting those elements. And there's the resulting control line. Okay? So through this process, I know we're about 5 minutes over, but I wanted to make sure I get that control line in there and show you how I'm accomplishing that. Again, ultimately, the point here for all of this is to look at the objective of where we're going with the modeling next week. So in our session, we created the baseline, the horizontal alignment, and we created the PGL, of course, to control the overall roadway corridor that you see here. You see it in 3D here. And we created control lines to control the horizontal tapers as well as the vertical transition in the bifurcation between the two roadways. And so as we run through this series, as we walk down these cross sections, you can see how the pavement is going to interact when Scott builds this corridor next week. Okay. All right. So